This video is about correlation and regression analysis using Python. I will start with correlation analysis. Correlation analysis is a statistical technique used to measure the strength and direction of a relationship between two variables. We start with installing these libraries, and this is a code we use: pip install pandas, numpy and scipy. I execute this command, and the next step is to import these libraries. Import pandas as pd, import numpy as np, and from scipy stats import pearson. If I execute this command, the next step is to import data file. So that data file is on my computer, so I'm going to import it into Python, and I will give this name Corel, but it's your discretion. You can choose any name. The core code is pd.read_csv, and then this is the path of destination, and this path is unique to every computer, so you will be using different path. I will execute this command, and then the next thing is I want to see what is included in my data. What are variables? So I can choose either of these. I can either use Corel head or Corel tail. If I use this command, that's Corel.tail parentheses, that will show me bottom 6 rows of my data. These are our variables: marketing spend, number of employees, business age, and sales revenue. It also shows there are 99 observations. I want to find correlation between business age and sales revenue, so these two variables. So for that purpose, I will define these two variables. I call one of them x and the other one as y. When I define it, it becomes x is equal to Corel, which is the name of the file, followed by variable name. And for y variable, again, it's the name of the file followed by name of the variable. Once we define these variable, in the subsequent steps, we don't have to mention this full name. We can only use x and y. I will execute this command. In the next step, we will calculate correlation. And the basic code for correlation is this one. That's NP. NP comes from numpy dot correlation coefficient and within parentheses x and y. I will execute this command, and it shows me that the correlation between these two variables x and y, or in other words, the correlation between business age and sales revenue, is 26.56%. Next, I want to calculate p-value, probability value, and for probability value I will use this code. If I execute this command, it shows me that p-value is 0.0075, which is a very small value. It is less than 5%. It means that the correlation that we find over here, and this correlation is based on 99 data points. As you can see, we have 99 observations. So this correlation will also hold in the broader population. The next analysis is regression. In regression analysis, we have a dependent variable and multiple independent variables. So we will start with installing libraries, and these are libraries that will be using pip install pandas scikit-learn. I will execute this command, and then the next step is to import these libraries. Import pandas as pd, and from scikit linear model import linear regression, and from scikit-learn matrix import mean squared error. I will execute this code. The next step is to import file. This file, it is on my computer, and I want to import it into Python. I give it this name, sales, although it's your discretion, you can give it any name, is equal to pd.read_csv, and then this is the path of destination of that folder and the file. That will be different in every computer. I will execute this code, and in the next step I want to see what's included in my variables. So I am using this code, that's sales.tail and then parentheses open and close, and that will show me bottom 6 rows of my data: marketing spend, number of employees, business age, and sales revenue. And it's very intuitive that sales revenue is a dependent variable, whereas marketing spend, number of employees, and business age are independent variable. In the next step, we will define these variables. These three variables will become x variable, and sales revenue will become a y variable. So in the next step, we define variables. X is equal to name of the file, sales, followed by all these three x variables. For y, the same thing, that's sales name of the file followed by name of the variable. The only difference that you can notice here is that for X variable, there are 3 independent variables, and therefore we see 2 square brackets here and 2 square brackets here. In case of Y variable, there is only 1 dependent variable and there is only 1 square bracket closing and opening. When we define these variable, it means in the subsequent steps we don't have to mention these independent and dependent variables separately. We can only mention X and Y. I will execute this code. For regression analysis, this is the code, which is model is equal to linear regression parenthesis model dot fit X and Y within parenthesis and Y underscore predict is equal to model dot predict within parenthesis X. I execute this code, and the last step is to print these results. I want to print out coefficients, intercept, R square and mean squared error. So it shows me that these are coefficients. These are coefficients of independent variable. So these 3 variable, marketing spend, number of employees and business age. These 3 are coefficients of those independent variable. This is intercept, which means when the value of X is 0, the value of Y is this one. And then it's R square 0.972, or in other words 97.2%, which means there's a very strong correlation between independent variables and dependent variables. And the last thing is mean squared error.